Good morning, Blue Cultural Group. It's Mr. T here for an astronomy class. And today, our subject is the formation of our solar system. And before I go to that, I want to give you a little bit of review of where we were last in our last lesson with the birth and death of stars. It's really important to know that stars are born, you remember, in the nebula as nitrogen accretes, and eventually the nuclear furnace, the fusion furnace inside the star ignites, and the star starts to burn with super hot temperatures. And then it goes through this life cycle of fusion of the elements. Nitrogen fuses into helium and fuses into the heavier elements over time, and eventually, over billions of years, the stars die. And some of them die forming a supernova, where the pressure of the fused core of iron gets to be so great and the heat gets to be so great that it explodes. And when a supernova occurs, it sends out into the universe, into the nebula around it, all of the heavy elements and the dust that compose the star. Well, our sun is a third generation star. That means, let's look at your family. So you have your grandmother, that was the first generation. You have your mom, that was the second generation. And you have you. So you're the third generation in your family going back to your grandmother. Well, our sun is a third generation sun. And what that means is it's really important because in the nebula where our sun was formed and born, there had previously been stars in there that had died. And when those stars died in a supernova, they sent out all of these elements, these heavy elements, into the nebula around the dust cloud. And so the elements necessary to form our planets, our solar system, and certainly planets with life on them like our Earth, those elements didn't exist in the first generation of stars. It took several generations, 3, before our solar system was created by the birth of our sun, our star, as a third generation star. So that's the background we need to have, understanding where our sun came from, our star. So, the nebula we're talking about here, the one that interests us most, was kind of 3/4 of the way out from the center of the Milky Way galaxy. And you recall, this is what nebulas really look like. And this is a Hubble Space Telescope picture of a nebula. And these are the birthplaces of stars. And you can see clouds of dust and elements. And they're mature stars in here, and they're stars that are just forming their life. So the nebula is the birthplace of the stars, and it's the birthplace of our third generation star, our sun. Well, when I was creating my materials for astronomy classes, I came up with some ideas, some images of what it might have looked like. So these are my drawings for the formation of our solar system. So, the nebula, and this is my art approximation of what a nebula looks like. Nebula is the nursery of the stars. We're not sure exactly how it happened, but apparently there was a supernova explosion near our nebula, in our nebula, and the shock waves of it hit the nebula and set it spinning. And it started spinning, it spun faster and faster, and it spun into a kind of flat disk, kind of like a frisbee. And that cloud of gas and dust condensed into smaller and denser clouds, and then as gravity pulled the elements together, molecules began to form. Molecules are groups of elements. And so we had the heavy elements, the carbon, and the oxygen, and the manganese, and the silicon. And those elements began to fuse together and to form these complex molecules of matter. the gravity of these lumps began to pull more and more material, more and more matter into the spinning formation of our solar system. And as the dust and gas accreted together, it formed these lumps. And the lumps were eventually planetesimals. Planetesimals were the primordial, the first planets, the formation of the planets, and they began to form. The planetesimals continued to spin in that flat plane like the Frisbee, and eventually circulating around a core. And that core became denser and denser, and eventually that core of nitrogen, of hydrogen, that core of hydrogen accreted sufficiently that it formed our star, our sun. And our sun burst into nuclear fusion and started to burn. And that's the picture that I draw here. So, as the nuclear fusion happened and the explosion of our star burst into life as our sun, it set the inner planets forming. The solar wind from the fusion explosion boiled up and blew away all the light gases, and it left the rocky planets, Mercury, Venus, Earth, and Mars, closest to the sun, while it blew away the lighter gases further out into our solar system. So there's our sun with the early formation of our solar system, our planets, and the gaseous giants, the outer planets of Jupiter, Saturn, Uranus, and Neptune were formed much farther away from the sun. They have small, rocky, icy cores, and they're surrounded by kind of a liquid, very cold, gaseous core, but these are the outer planets. In addition to the outer planets and the inner rocky planets, a lot of debris left from the nuclear fusion explosion of our star, of our sun. A lot of the debris left formed the asteroid belt between Jupiter and the planet Mars, a rocky planet. And those asteroids continue to circulate around the sun, and occasionally they leave, and the pull of gravity of the planets pulls them in and close to the Earth's atmosphere, and we can see them in meteorites that fall into the Earth's atmosphere and burn up, and that's the debris left from the formation of the solar system that continues to rain down on Earth and on the other planets, pulled there by our force of gravity of our Earth. So the formation of our solar system started about 10 billion years ago. That's how old our sun is. And our Earth, that was a mistake. So checking my notes, the formation of our solar system was about the universe was already 10 billion years ago old. Remember, the Big Bang, we believe, happened 4.6 billion years ago. Well, our solar system is only 4.6 million years old. So our sun ignited its nuclear furnace about 4.6 billion years ago, and scientists believe it's got about 5.5 billion years left to burn before it too becomes a supernova and collapses into a white dwarf star, as we talked before. So, and that's the formation of our solar system. I'm going to give you an interesting worksheet so you can name our planets from this lesson, and I'll be back with you again tomorrow to explore our planets. And this is Mr. T signing out on the formation of our solar system. Take care.